Alright, so in this video we're going to talk about how to convert a standard form quadratic function into a vertex form quadratic function. Last time we gave the function f of x equals minus 2x squared plus 4x plus 1 and also said that this was its vertex form. Another example that was in the previous video was g of x equals to x squared minus 6x plus 9. And it was easy to convert this into vertex form without much instruction because all we had to do was factor it. It just turns out that g is already a perfect square, and the vertex form is pretty much given to us for free in this case. But as we saw a long time ago, it's not a guarantee that a quadratic is going to factor as a perfect square. And if this is ringing some bells, it definitely should, because this is going to bring up everyone's favorite tool, which is called completing the square. We're going to present this process in a way that's familiar and almost identical to what we did for quadratic equations, but completing the square is how we go from standard form to vertex form. Now, this video does assume that you are somewhat comfortable with completing the square, so if you do need to go back and watch the video that talked about how to do this in the first place, I recommend doing so before proceeding. And as not to send you on a wild goose chase, this will be the second video for section 1.8. So first and foremost, we essentially have two trivial cases. The one where our quadratic is already a perfect square, like in the example x squared plus 4x plus 4, because turning it into vertex form just means factoring. Another trivial example is when I have ax squared plus c. All I have to do is rewrite what x squared looks like, and boom, you're in vertex form. Now, of course, we're going to go to the non-trivial case. Let's look at the example again, f of x equals negative 2x squared plus 4x plus 1. Here we'll actually give you the big reveal into how we turn this into vertex form. Recall that whenever I complete the square, I have to make note of the a, b, and c values. Here, a is equal to negative 2, b is equal to 4, and c is equal to 1. When we have this information, we can compute the quantity b over 2a squared, which in our case is negative 1 squared, that turns into positive 1. Normally when we're completing the square, we'll have a quadratic expression set equal to 0. But I'm not going to do that here because I have a function. What I'm going to do instead is just flip the way our function is written. I'm going to write it instead as negative 2x squared plus 4x plus 1 equals to f of x, with our f of x on the right hand side. And then the first step of completing the square says to take your constant term and move it over to the right hand side. Now I have an a value not equal to 1, so I'm going to divide everything by the a value of negative 2. This gives me x squared minus 2x equals to f of x minus 1 divided by negative 2. Now I'm going to add our b over 2a squared term to both sides. Since in our case that's a 1, I add a 1 to both sides. This gives me x squared minus 2x plus 1 equals to 1 minus f of x divided by 2 quantity plus 1. Does the right hand side look weird to you? It probably should, because now terms are flipped around a little bit. What I did, and this is just a nice algebraic trick to make our expressions look a little bit nicer, is I took that negative attached to the 2 in the denominator and I placed it in the numerator. Multiplying the numerator by negative 1 essentially flips the sign of everything, and I just rearranged the terms to make it a little bit nicer to look at. But now that we're here, we're going to factor our left-hand side, which is the whole point of completing the square. The left-hand side will factor as x minus 1 quantity squared, and our right-hand side will stay the same. Now, if you remember completing the square correctly, you would know that this would have been the last step. The square is essentially completed, but this doesn't really look like vertex form. This is definitely not what I gave us in the previous slide. Even though completing the square has concluded, we still have an extra step. Essentially what we have to do is solve for the character f of x. This is why when we were doing linear equations in one variable, we solved for terms that were in these complicated expressions with a whole lot of characters. We can use linear solving techniques to isolate f of x and get our vertex form. If I want to start isolating f of x, let me get all constant terms over to the left-hand side. I'm going to subtract a 1 from both sides, which is going to give me x squared minus 2 squared minus 1 is equal to 1 minus f of x over 2. Again, the goal is to isolate f of x by getting it on its own side of the equation. First, let me clear that fraction by multiplying both sides by 2. This is going to give me 2 times quantity x minus 1 squared minus 2 is equal to 1 minus f of x. At this point, it just takes a little bit of algebra, but we can finally solve for f of x and find that f of x is equal to negative 2 times x minus 1 quantity squared plus 3. And then we can verify that this function does have a vertex of 1, 3. So essentially taking a standard form quadratic and turning it into vertex form is a two-step process. You begin by completing the square, and once that's done, you solve for f of x. We'll conclude the example with a harder example. And I only call this a harder example because this one has some more fractions involved into it. So even though the actual concept here isn't going to be any different, it's just a little bit more tedious because the numbers are a little bit less convenient. But that's the whole point of this example, is to show you what the harder examples actually look like and how to work with them. So just like before, use the a, b, and c values to compute b over 2a squared. In our case, that's going to be 5 over 6 squared, which is 25 over 36. Next, we're going to write our function as 3x squared plus 5x minus 1 equals to g of x, and then we're going to move the constant term to the right-hand side. This will give me 3x squared plus 5x equals to g of x plus 1. Now the rule says whenever our a value is not equal to 1, we have to divide both sides of the equation by our a value. In this case, our a value is positive 3, so we're going to have to divide both sides by positive 3. And this is where some of our fractions are going to come in. We're going to end up with x squared plus 5 over 3x equals to g of x plus 1 divided by 3. Now that we're here, we're going to take our b over 2a and add it to both sides. This gives us x squared plus 5 over 3x plus 25 over 36 equals to g of x plus 1 divided by 3 plus 25 over 36. Now what you're going to see in the notes corresponding to this video is that at this point I will have combined the fractions on the right-hand side. In this video I don't do that. Here I'm showing an alternative approach that avoids combining the fractions on the right-hand side, and at which point you can pretty much decide which one you like better. So I'd say look at this example in the video, look at the corresponding solution in the notes where I do combine those fractions, and pick your favorite. Now, when we're factoring the left-hand side here, you can factor it by hand, which will be hard, or you can remember that there is a formula associated with this. The left-hand side will factor as x plus b over 2a quantity squared. So for us, that's going to be x plus 5 over 6 quantity squared. Again, if that step doesn't quite ring a bell, I recommend going back to the completing the square video. Again, this is the second video for section 1.8. Now that we're here, all I need to do is try and solve for g of x. I'll begin this process by subtracting the fraction 25 over 36 from both sides. Next, I will multiply both sides by 3 to sort of help clear that fraction that g of x is involved in. This is going to give me the quantity 3 times x plus 5 over 6 squared minus 25 over 12 equals to g of x. Now to solve for g of x, all I have to do is subtract a 1 from both sides. I'm going to realize that 1 is the same thing as 12 over 12 to help me simplify that numeric fraction. But once I have all those steps simplified and I have solved for g of x, I'll find that g is equal to 3 times x plus 5 over 6 quantity squared minus 37 over 12. And this is going to give me a vertex of minus 5 over 6 and minus 37 over 12.